All right. Good afternoon, you guys. Okay, so we are on 1.3 and 1.4 today, so it's going to be a 2-in-1 lesson. So it's going to be a little longer than usual. Well, it might not even be that bad because both of these are kind of short lessons anyway, but we have to condense it because with this whole block schedule, we lose one instructional day per week. And when we add that up over the course of the year, that's a lot of days. So I have to try to condense everything. So occasionally we're going to have a lesson that's a little bit longer than what we're used to, but it's block scheduling. So at least it's kind of like how it would be in college where things are kind of at your pace. You still have due dates and stuff, but like you get to work on it on your own. Okay. So our learning targets today are to develop the power of a power property, the power of a product property, and the power of a quotient property. Remember, product means when we multiply things together, quotient means when we divide things together, and we're going to simplify expressions involving exponents. Okay, so it says write each expression in standard form, and then we're going to write it as a single exponent with a given base. The first one has been done for us. My printer is so horrible right now, and that's probably because I buy the cheapo ink instead of the brand, the Hewlett-Packard ink like I should be buying, but it's like way cheaper to get the cheapo ink, so whatever. Okay, so I have 2 squared to the 4th power. So that means we have 2 squared times itself 4 times. So 2 squared, 2 squared, 2 squared, 2 squared. And then when I break up all those 2's, I have 2, 2, 2, 2, 2, 2, 2, 2. So that's 2, 4, 6, 8 2's. So 1, 2, 3, 4, 5, 6, 7, 8. That makes this a 2 to the 8th power. You know what? Let me use a darker color so that we can see that. 2 to the 8th. It's a little bit better. Okay, so the next one, 5 to the 5th to the 3rd power, means I have 3 5 to the 5ths. So 5 to the 5th times 5 to the 5th times 5 to the 5th, which means I have 5, 10, 15 5s. So I don't want to write out 15 5s multiplied together. So that just means I'm going to have 5 to the 15th power. Okay. All right. I hope you guys are seeing a pattern there. On this next one, I have x to the 3rd to the 4th power. So that means I'm going to have 4 x to the 3rds. So x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd. So that means I'm going to have 3, 6, 9, 12 x's. I don't want to write out 12 x's. I'm just going to write that this is going to be x to the 12th. It's the same thing as adding 3, 6, 9, 12. Okay. All right. So what's the pattern then? Can we tell what it is? 2 squared to the 4th power. Well, how can we quickly get that would be to the 8th power? What do we do with these numbers? And what do we do with these numbers? And what do we do with these numbers? That's right, we multiply. So 2 times 4 is 8, so it was 2 to the 8th. 5 times 3 is 15, so 5 to the 15th. 3 times 4 is 12, so x to the 12th. Okay, so when we have a power raised to a power, we multiply those exponents. So based on the pattern you observed in item 1, write the missing exponent in the box below to complete the power of a power property. So I just always call it power rule whenever you raise a power to a power. So I'll call this power rule. Okay, so a to the m times n, a to the m raised to the nth power is a to the m times n is what I was meaning to go towards. Lucas, you're interrupting my lesson, so now you don't get to get out any sooner because you did that. Use the power of a power property to write x to the 6/5 power raised to the 25th power as a single power. Okay, so remember, power to power means that we multiply. So that means we'll have x to the 6/5 times 25. When we multiply fractions, you could put the 25 over 1, because you could put any whole number over 1, and then we can multiply straight across, or we can cross cancel. We could totally cross cancel here because doesn't 5 go into 25? 5 times? So 6 times 5 is 30. So this is x to the 30th power. Nice. So even though you have a fraction, it's really not that bad. Not that bad at all. It says write each expression in expanded form and group like terms. Then write the expression as a product of powers. The first one has been done for you. So I have 2x to the fourth. So that means I have 4 2x's. 1, 2, 3, 4 2x's. And then they grouped it by 2's. 2, 2, 2, 2. And then the x's, x, 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 x. So 2 to the fourth, x to the fourth. So basically what they're saying is that power is being distributed to each of the terms that it's being raised to. The parentheses is containing all of those terms that are being raised to that power. So everything in the parentheses has to be raised to that power. Now, for example, if it was 2x to the fourth power, the power of that 4 is only on the x. But the parentheses around the 2x raised to the fourth power tells us that the 4 power goes on the 2 and the x. Okay, so let's just go straight to the answer for these. If we have -4, a to the third, that means we have to distribute, that's basically what it is, the power to both terms there in the parentheses. Now, because that 4 is a -4, you need to keep it in parentheses so that the negative gets raised with the power also, because -4 to the third does not equal -4 to the third. Actually, in this case, it does because it's an odd power. But anyways, so it does equal, but if it were an even power, it wouldn't work. So you're lucky when we have an odd number of negatives, the answer is still negative no matter what. So with an odd power, it won't matter, but you need to be in the habit of putting parentheses around negative numbers. Okay, capiche? Okay, and then a to the third. All right, for this one, I have x cubed y squared, so we need to bring that power to both those terms. But remember the power rule. When you raise a power to a power, you multiply the exponents. So x to the third raised to the fourth will be x to the 3 times 4, which is 12. Y to the second raised to the fourth power is y to the 2 times 4 power, which is y to the 8th. Okay? All right, turn the page. Okay, number 5, it says, based on the pattern you observed, write the missing exponents in the box to complete the power of a product property. Whoops, sorry, I don't mean to. Power of a product property. This is still technically power rule, but they want to show the difference when it's one term being raised to a power versus multiple terms raised to a power. There's got to be parentheses around the terms being raised to that power, and that's how you tell that you distribute that power to all the terms in the parentheses. So AB raised to the m power is a to the m, b to the m. Okay. Use power of a product property and power of a power property to write each expression as a product of powers. Okay, so let's zoom in here. Okay, so we need to distribute that power of 8 to both terms in here. So that'll become c to the 1/2 times 8, d to the 1/4 times 8. Like I said, when you're dealing with fractions, make the whole number put over 1. You can do that to any whole number. 2 goes into 8 4 times. 4 times 1 is 4. 4 goes into 8 twice. 2 times 1 is 2. So this is really c to the 4th d squared. Next one, we have to raise m to the 12th, n to the 20th, all to the 3/4 power. So we have to distribute that power, which means when we have a power raised to a power, we multiply. So we're going to have m to the 12 times 3/4, n to the 20 times 3/4. Like I said, put the whole numbers over 1. Helps you visualize what you got to do. 4 goes into 12 3 times. 3 times 3 is 9. So that is m to the 9th power. For the n, 4 goes into 25 times. 5 times 3 is 15. So we have n to the 15th power. Easy peasy. All right. It says use patterns that you have seen, and it says predict and write the missing exponents in the boxes below to complete the power of a quotient property for exponents. So power of a quotient means you're dividing, so that's with a fraction. So notice how they didn't even give you an example about this. They just automatically want you to assume what you got to do, and it's still the same concept. If we have a term raised to a power, everything in that parentheses gets raised to that power, and that includes distributing to the numerator and to the denominator of a fraction. So a over b raised to the m power is a to the m over b to the m, where b can't equal 0, but b can't equal 0 because it is in the denominator. Okay. So number 8, it says use the power of a quotient property and the power of power property to write each expression as a quotient of power. So aka simplify it. So we're going to simplify those. So let's first look at, we have x to the third over y to the 6th, all raised to the 1/3 power. So that means we're going to have x to the 3 times 1/3, because power to power we multiply, over y to the 6 times 1/3. If it helps, put them over 1. The 3's cross cancel, because a third of 3 is just 1. So this is just an x in the numerator. In the denominator, 3 goes into 6 twice. 2 times 1 is 2, so we have y squared. X over y squared is that final answer. Letter B, p to the 3/4 over q to the 5/6, all raised to the 24th power. So power to power means we multiply. So p to the 3/4, oops, that's a 4, times 24, put that over 1, all over q to the 5/6 times 24 over 1. Let's see, 4 goes into 24 6 times. 6 times 3 is 18. So that numerator is p to the 18th power. All over, let's see, 6 goes into 24 4 times. 4 times 5 is 20. So q to the 20th. P to the 18th, all over q to the 20th. You guys getting it? All right, you can apply the power properties and the exponent rules that you have already learned to simplify expressions. So example A goes over simplifying a problem that is going to be using, let's see, I see product rule. I see the power rule, because we're going to have a power raised to a power. I see a negative exponent. So I see 3 different properties that we're going to be using here. Okay? So I want to do this example over to the right because I feel like you need an explanation of what this example is going to entail. So I'll put it over here. This is example A. And we are going to simplify 2x to the 2nd, y to the 5th, raised to the 3rd power, times 3x squared to the negative 2nd power. When I see 0 exponents or negative exponents, that is the first thing that I want to handle. You can handle the other stuff first if you want. It's not going to affect the answer as long as you do it right. But when we can take care of the negative exponents and the 0 exponents first, it's going to save us some trouble that we might run into, or areas where we might get stuck if we go another route. So I always say, get rid of the negative exponents and the 0 exponents first, okay? So notice this term, the 3x squared is raised to the negative 2nd power. So that since this whole thing is raised to a negative exponent, we got to drop it like it's hot. Okay? So when we drop it like it's hot, the other term, the 2x squared y to the 5th, all raised to the 3rd power, it didn't have a negative exponent. It's still up there in the numerator. And the denominator now we have a denominator. It'll be 3x squared raised to the positive 2nd power. When we drop it like it's hot, when we invert it, that's basically what we're doing. It's going to change that negative exponent to a positive exponent because we flipped it down to the denominator. Okay, now we can do the rest of the problem. All right, so we can go ahead and distribute this power of 3. There are 1, 2, 3 terms inside the parentheses. We have to raise it on the 2, raise it on the x squared, and raise it on the y to the 5th. Okay, so 2 to the 3rd, 2 times 2 times 2. Well, 2 times 2 is 8. 2 times 2 is 4. 4 times 2 is 8. Whoops, that was about to be a mistake. X squared to the 3rd power. Power to a power we multiply. 2 times 3 is 6. So that's an x to the 6th. Y to the 5th raised to the 3rd power. Power to a power we multiply. 5 times 3 is 15. So that's y to the 15th. That's our numerator. In the denominator, we also have to distribute that power of 2 to both terms that are in the parentheses there. 3 squared is 9. X squared squared, power to power we multiply, 2 times 2 is 4. But we're not done yet because we can still simplify. 8 over 9 doesn't reduce. Can't do anything about those numbers. But we have an x to the 6th over x to the 4th. So we have something in common still. We can cancel out the x to the 4th with 4 of them from the top. 6 minus 4 is 2. And that's everything. So my final answer is going to be 8x squared, y to the 5th, all over 9. Easy peasy lemon squeezy. Okay, that was example A. Example B has to do with, I see a fraction, so that means we have a quotient. We're dividing. I see a negative exponent, and that's it. And then I see power rule because we have this whole thing raised to the 2nd power. Okay, so let's go ahead and do example B on the left. I'm sorry, I'm left-handed, so I have to turn the page so I can write straight or try to write straight. So we have x squared y to the negative 3rd over z, all raised to the 2nd power. Okay. Remember what I said? What we need to start with? Negative exponent. So let's get in that habit. So I have a negative exponent in there. I'm going to circle it so that I know where it's at. And I got to drop it like it's hot to invert it. So I'm going to have x squared still up on top. There was nothing wrong with it. It did not have a negative exponent. In the denominator, I have a z. But when we have letters and there's different letters, we need to make sure we put them in alphabetical order. So I need to put the y to the positive 3rd first because it's positive down there. We inverted it. And then the z. Quantity squared. Okay, so now we can distribute that power of 2 to everything there. So x squared squared, power to power we multiply, that'll be x to the 4th. In the denominator, I have y to the 3rd squared, power to power we multiply, 3 times 2 is 6, so y to the 6th. And then z, even though that z is just to the 1 power, 1 times 2 is 2, so z squared. And boom, shakalaka, there we go. Here's try these A through B. So we could try these. I'll try a couple of these because I don't want to go through them all. We're kind of pressed for time. So let's see. If we were in class, I would ask you guys which ones you would want to do. And I already know E's going to look big, so you're going to want me to do that. And I kind of want to do C because there's a negative exponent on that fraction. How do we do that? And I'll just do those two. Okay. Let's start with C. Anytime you have a fraction and everything in there is being raised to a negative power, here's what you got to do. Remember how you have to drop it like it's hot or throw it up to change it to a positive power? Well, when it's a fraction, you just have to invert it. To invert a fraction, what do you guys do? You flip it. I already have ink all over me. Oh my gosh. Okay, so to change that power to a positive power, all we have to do is flip the fraction. So put the y to the 3rd up top, put the 4x on the bottom, and now that exponent is a positive 2. It's a neat little trick, and you can use it every time that you come across this. Okay, so now we need to distribute that power of 2 to the numerator And then in the denominator, we have 2 terms, so each of those terms gets it. So we have y to the 3rd squared. So power to power, we multiply. 3 times 2 is 6. That's y to the 6th. All over. 4 to the 2nd power. 4 times 4 is 16. And then x to the 2nd power. And that's it. There's nothing else we can reduce out of that. They're really not that bad. I know they look really long, but just focus on one thing at a time. And as you focus on one thing at a time, you'll be fine, okay? All right, so here I see a couple negative exponents. I see one of these in the parentheses. It has a negative exponent. And I see everything in that parentheses is raised to a negative exponent. So I want to start there. That whole thing is being raised to a -1. So we got to drop it like it's hot. So that means we need a fraction. Okay. Now this one, because it is tied to that 3x, so it goes 3x y to the -2nd, all this is stuck together until it's raised to the 2nd power. We're going to need to raise to the 2nd power first before you drop it like it's hot. So this one's a tricky one. We have to take care of that exponent first and then the -1 there. The negative exponent there, okay? So let's drop this one like it was hot, and we'll get 3xy to the -2nd squared times 2x cubed yz all over 6yz squared, now raised to the +1 power. When you raise something to the 1st power, does anything change? You should be thinking, no, Mrs. Garcia, nothing changes when you raise it to the 1st power. Sorry, I talk to myself a lot. That's what happens. Okay, so since that's to the 1st power, I can lose the parentheses and raise it and the raise to the 1st power in that denominator there. I no longer need it because it's not going to change anything. All right, so now the next thing I've got to do is I have got to raise this 3xy to the -2nd all to the power of 2. And then I can take care of that other negative exponent. So 3 to the 2nd power, 3 times 3 is 9, x to the 2nd power, y to the -2nd raised to the 2nd, -2 times 2 is -4, so y to the -4th, and then we have times 2x cubed yz. Now technically I don't need parentheses to show times because when letters are next to each other, I can just use a dot or just put them next to each other. Because that 2 is still there, I could use the dot or I could use the parentheses. All over 6yz squared. Okay, so I'm not quite done with it yet. I still have to finish things off. So here's where I'm going to start condensing some of these steps. I'm going to circle this. We got to invert it. We can now drop it like it's hot. It is set free. We can do it. Okay. In the same step, I'm going to group things together. 9 times 2 is 18. I have x squared times x to the 3rd. So remember when we multiply like bases, we add the exponents. 2 plus 3 is 5. And then we have the y gets dropped. So the only y up there is that one y. And the only z up there is that z. All over. Now in the denominator, I'm going to have 6. I have a y to the 1st that was already there, and now these 4 are coming down here. So 1 plus 4 is 5, z squared. I'm not quite done yet because, sorry, my pens are out of order. I can cancel out the z. Oh, there's 2 z's in the denominator, so just one of them. So that z is still there, but to the 1st power. I can cancel out that y with one of them down here, so that's a y to the 4th. So my final answer is going to be 18 x to the 5th. Those 2 canceled, all over 6 y to the 4th z. You could put to the 1st power. It doesn't hurt anything, but you don't need to because when there's no power there, we assume it to be a 1 anyway. Okay. All right. Oh my gosh, I got ink all over the place. All right, we're going to skip all this anyway, so that's okay. All right, so we're back to the end pretty much. So we'll go on to the next half of the lesson. So the next half is 1.4, starting on page 14. Okay, so 1.4, we are going to rewrite. Oh my gosh, I have like ink all over me. Sorry about that. I had to go wash my hands because these pens are supposed to be so good and they're leaking all over me. All right, we're going to rewrite powers that have variable exponents, and we're going to use properties of exponents to transform expressions for exponential functions. Okay, you learned about exponential functions, exponential growth and decay in Math 1. So I know it's been a little while since then, but you have learned about them. All right, so number 1, each expression contains a variable term and an exponent. Use the power of a power property to rewrite each expression so that the variable exponent does not have a coefficient. The first one is done for you. Okay, so they just want you to rewrite these expressions. So they have 8 to the 2t, and then they break it up. 8 to the 2t is basically 8 to the 2 times t, and then we can just write 8 squared raised to the t power. And then what's 8 squared? Oh, 8 squared is 64. Okay, so that's what they want us to do here. Okay, so in the first one, we have negative 2a all raised to the 5x power. Okay, all right, so let's break that up. Let's make this negative 2a to the 5 times x power, because that's really what that is. 5x means 5 times x, right, guys? Okay, and then from there, let's make this negative 2a raised to the 5th raised to the x, because power to power means you would multiply 5 times x anyway, right? Right, guys? All right, so now we can take care of that negative 2a raised to the 5th power, and we can distribute that power of 5. Okay, so let's do that. Remember, everything will still be raised to the x power. So negative 2 to the 5th will be negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Okay, so that's 5 times. Negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. Negative 8 times 2 is, negative 8 times negative 2 is 16. 16 times negative 2 is negative 32. I knew it was going to be negative, though, because anytime you have a negative raised to an odd numbered power, it's still going to be negative. And then a to the 5th is just a to the 5th. Okay, so we have negative 32, a to the 5th, raised to the x power, and we're done. We separated it. For the next one, 1/16 to the 3y over 4 power. Okay, so to separate that, we have basically 3/4 times y. So you could write that as 1/16 to the 3/4 times y power. Okay, and then from there, we can separate even further and make it 1/16 to the 3/4 power, and then that raised to the y power. And then what we can do is we can distribute that power of 3/4 top and bottom. So we'll have 1 to the 3/4 over 16 to the 3/4. Okay. And then this is all raised to the y power. And to simplify that even further, we need to talk about some things. So over to the left, let's take this over. 1 to the 3/4 power. Okay. Well, 1 to any power is still going to be what, guys? 1. Yep. 1 to any power is still going to be 1. So that one was easy. 16 to the 3/4 power. Well, whenever you have a fraction like this and you can't simplify it further, you actually can simplify it further. The denominator tells you what kind of a root it is. So because it's a 4, that means this is a 4th root. You know how we have square roots? This is a 4th root of 16 to the 3rd. Do you know that in our calculators we can evaluate that? But I need my calculator in order to do that. Here it is. Okay. So to do a 4th root, you hit 4. the second button. And then do you guys see this little up arrow button where my thumb is? Behind it in green, it says an X and then square root. That X is the type of root it is. This one down here, it's just a regular square root. This one, I can make it any root I want. So I have to hit the 4 to tell it to be a fourth root, and then second, and then that up arrow. Oops, I must not have hit second. 4, second, and then the little up arrow button, and then it does the square root. But I'm telling it to be a fourth root of 16 to the third. So 16 to the third power. And it's 8. Isn't that cool? So 1 to the 3/4 power is just 1. 16 to the 3/4 power is just 8. And all that is raised to the y power. Okay. And then we'll skip doing the last one. Okay. All right, so each expression contains a variable exponent. Use a power of a power property to rewrite each expression so that the variable exponent contains a coefficient. The first one is done for you. So now we went forwards in number 1, and now we need to work backwards in number 2. So 125 to the s power, well, 5 to the third is the same as 125. 5 times 5 times 5 is 125. So then we would have 5 raised to the 3 power raised to the s power, so 5 to the 3 times s, 5 to the 3s. So they want us to do that here, 8 times 27 to the r power. Now, don't multiply 8 times 27. You're going to get a huge number, and you don't want that. 8 and 27 can be written as a number raised to a power. 8 is the same as 2 times 2 times 2. So 8 is the same as 2 to the third. 27 can be written as 3 to what power? 3 to the third is 27. Okay, there's a start. Well, these are both raised to the third power, so that means I could take that 3 and boop, bring it back up there on the exponent. Basically undo the distribution. So I have 2 times 3. Bring the 3 back outside on the exponent. 3 times r is 3r. 2 times 3 is 6. So we have 6 raised to the 3r power. Isn't that crazy how we can go forwards and backwards like that? Now I know that might seem a little confusing, but it's okay. You'll practice it and you'll get good at it. All right, so I'll just do that one. Number 3, how are the steps you followed in items 1 and 2 alike? How are they different? Well, both are using power to a power, so both are using power rule. Both use power rule. Forwards and backwards. Okay. Now this first example has to do with something real for you guys. Okay. So when we talk about exponents in math, exponents are not just simplifying math problems and until there's no more negative or zero exponents or until the fractions are reduced. It's not just about that. That's part of it. That's part of the skills that we need in order to do the math that pertains to real life stuff. Okay. Real life stuff like things like interest rates that you're going to have to deal with when you get your own credit card or when you buy your first car or when you have to make your first credit card payment. How long is it going to take you to pay it off with the interest on top of that? Because it's not just the money that you're using on that credit card. You also have to pay interest on top of paying that money back. So there's a lot of things that go with that. When you buy your first house, like it's just all of that involves interest. Okay. All right, so example A, it says an investment earns annual interest at a rate of 4.6%. That seems mighty important, so I'm going to highlight that, rate of 4.6%. Find the monthly interest rate. So we're going to find whatever the monthly interest rate is, okay? So it says write an exponential expression for t years, 1.046 to the t power. So they got the 0.046 because the interest rate is 4.6%. This is how much you earn. So on top of that, it's always going to be 1 plus that percent. And that percent as a decimal is 0.046. Okay, so 1 plus 0.046 is 1.046. And T stands for time. You learned this formula in Math 1, so it's been a little while. Okay, we'll get some practice with it, promise. All right, so what we need to do is we need to figure out the monthly interest rate. Okay, right now we have the annual. What does annual mean? Yearly. We have the yearly interest rate. What would it be per month is what they want. Okay, well, how many years are in how many months are in a year? 12. So if this is representing 1 year, I need to multiply this by 12, which means I have to keep it equally balanced, and I have to make sure that I divide out the 12 on the inside. Because I need, when I multiply this back out, 1/12 times 12t using the power to a power property, I need the 12s to cancel and it still go back to t. All right, so now what we can do is we can raise this 1.046 to the 1/12th power. Because that's a fraction, you have to use parentheses to tell the calculator what you're supposed to do. If you don't use parentheses, it's only going to raise it to the first power, and then nothing's going to change. But the number should change. It's 1.003, and then they rounded it to an 8. Okay, so that means that the monthly interest rate is just what we're earning. So after 100% of what we're earning, or on top of that is the interest. So the 0.0038. Okay, well, as a percent, if we move that decimal over until we get to the nearest, until we move it over, we always move it over twice because it's by times 100. Okay, I messed up there. So 0.0038. If we change this to a percent, it's 0.38%. Okay, so it's not a huge percentage, but think this is over the months. 4.6% over a year is actually a pretty good percent. Most bank accounts, like savings accounts, only earn between 1 to 2, sometimes 3%, depends. Credit unions are definitely the banks that earn the best interest on savings accounts. Okay. All right, so I want to go over example B. So it says a group of students is researching population growth using an annual growth rate of 0.85%. So there's that annual word again. Annual means yearly, so a yearly growth rate of 0.85%. A second group of students wants to study the same population using the growth rate per decade. A decade? What does a decade mean? Anybody know? A decade is 10 years. So we need to find the growth rate the second group of students should use. They want it over 10 years instead of annually. Okay, so what do we do about that? Well, the book already has it worked out, so let's follow the steps. Well, first of all, we have to set up. In the parentheses, it's always 1 plus the interest rate, which was 0.0085. Remember, it was 0.85%, so as a decimal, we have to move that decimal to the left twice, so it's 0.0085 to an annual rate, so to the t power for yearly, okay? So t is the time in years. So we have that. 1 plus 0.0085 is 1.0085, okay? Well, we have to think t years should equal 1/10 of t decades, okay? Because there's 10 years in a decade. So if we have t years, that one of those years would be 1/10 of that decade. So it says use the power property to write an equivalent expression with the exponent 1/10 t. So if we need it to be 1/10 of that, okay, because a decade or a year is 1/10 of a decade, we need to have the 1/10 t on the outside. But we need to make sure that the 10s can cancel, so we need to the 10th power on the inside because I need it to still be equivalent to this. So it really needs to be still the same power. I'm just changing it around a little bit to help me out. Okay, so 1.0085 to the 10th power is what we got to do. 1.0085 to the 10th power is 1.0883. And they put 0.088326. Okay, so this number right here is the decimal of the percentage, 0.088326. Remember, we got to change it to percent, so we have to move the decimal over to the right twice. So that's really 8.8326%. Okay. And then we have try these A through B, where we are going to convert each rate as indicated. Okay. So, did I have these worked out? So these will be good practice for you guys. Try these A through B. Sorry if I've said that twice. I had to pause it for a second. Okay, so an annual rate of 4.2% to a monthly rate. Okay, so we're going annual to monthly, just like we did in the first example, in example A. So remember, that'll be 1 plus this as a decimal. So this as a decimal means that we move the decimal over to the left twice. So that would be 0.042 to the t power. That's our normal one. But we need to change it to a monthly rate. Okay, so to change it to monthly, that means that in a year, we have 12 months. So we have to multiply a year by 12. Because now we're breaking up, instead of one time, we're going to find the interest rate 12 times in a year. So then to balance out that 12, we're going to need to have the 1.042 raised to the 1/12th power. Because I still need these two expressions to be equal. So for them to maintain their integrity, I got to balance them out. Okay, so now I have to raise 1.042 to the, it's a fractional power, so I have to use parentheses, 1/12th power. And I get this, 1.00343. So this equals 1.00343 to the 12t power. And it's asking us what the monthly rate is. Well, the monthly rate has to do with the numbers after the decimal point. So if we were to change that to a percent, then the percent monthly rate would be 0.343%. Okay, so that's the first one. Letter B, we have an annual rate of 6.4% to a quarterly rate. Well, how many quarters are there in 1 year? Well, there are 12 months, and it could be divided evenly into 4 quarters. Okay, so every 3 months. So there are 4 quarters in a year. So we're going to have this percentage. We got to change it to a decimal, so move it over twice. So that'll be 1.064 to the t power, our normal yearly rate. And then I got to switch it so that it's a quarterly rate. So that means that we're going to figure out what that interest is 4 times in the year. So 4 times t. But I need to balance that 4 out with a 1/4. It's reciprocal. Okay? That way, these are still equal expressions. It's still 1.064 to the t power. But now we can raise 1.064 to the 1/4th power. What is 1/4 as a decimal, guys? It is 0.25, right? So when I raise a non-fraction and a decimal, I don't need parentheses around a decimal. So if you want to convert the fraction to decimal first, you can if it's a nice fraction. And I get 1.0156. So this is 1.0156 to the 4t power. And I just need the quarterly rate, which is all the point and then on to the right. Not the 1. The 1 has to do with what it was before the interest rate. Okay, so that rate, I move the decimal over to the right twice to change it back to a percent, is 1.56%. Okay. Letter C, an annual rate of 1.5% to a decade rate. So first of all, we got to change that to a decimal again. So that'll be 0.015. So 1.015 to the t power. And we're changing it to a decade rate. How many years are in a decade? 10. So that means that we have to change out our exponent a little bit. So since there are 10 years in a decade, that means 1 year is a tenth of that decade. So to balance out the 1/10, we need to have a 10 inside the parentheses as an exponent in there. All right, that way these two are equal expressions. They're exactly equal. And now I can raise 1.015 to the 10th power. 1.015 raised to the 10th power is 1.1605. And that is to the 1/10 t power. Okay, so then the decade rate that I need is from the point on to the right. So 0.1605, and that as a percent, if we move the decimal back over twice, to the right, that is 16.05%. And then the last one, an annual rate of 0.224% to a generation rate. Did any of you know that a generation is 20 years? I didn't know that before I taught this, when I first taught it like several years ago. But I honestly didn't know a generation is 20 years. Okay. So you learn something new every day. Literally. Okay. So we need to convert this percentage to its decimal. And yeah, it is a decimal percent, but it's a percent. So we have to convert it to just a decimal. So we have to move that decimal to the left twice. So it'll be 0.00224. So 1.00224 to the t power. Okay. And to a generation rate. So it's just like the decade rate. So we're going from 20 years to 10 years. Or, that one was to 10 years, this one's to 20 years. Okay, so that means that a year is 1/20th of a generation. So to balance out that 1/20th, I need to have to the 20th power inside the parentheses there. Okay, so that these are equal expressions. And then I have to raise that in my calculator. 1.00224 raised to the 20th power is 1.045. We'll go 8. 1.0458. To the 1/20th t power. So the numbers from the decimal point on to the right are our new rate in terms of a generation, 20 years. So that would be 0.0458. So if we change that to a percent, move it over to the right twice, we'll get 4.58% as the rate. Okay, and that's how we do it. All right, so your homework is going to be on this. This is page 16 from your textbook. Now, if you don't have your textbooks, you also have access to Springboard Online. You do that with your English classes. So your math book is up there too with your English book. So that's how you can access the digital version of your book. But you should have gone to the campus and picked up your textbooks by now. We're going into the 4th week here. So you need to get doing that. If I see another complaint about not having a textbook, I'm going to need to call home and figure out what's going on. You guys need to have your textbooks, okay? So there was one person that had said that they didn't have a printer and they didn't have their textbook. Okay, if you don't have a printer, fine, but if you don't have your textbook, what's up with that? You should have gotten it already, all right? You know who I am talking to if you are listening. All right, so your homework is going to be, we're going to go through a review on lesson 1.1, 1.2, 1.3, and 1.4. There are 42 problems here though, so I don't want you guys to have to do all of those. So I'm going to choose Let's do 5 from each section. So for 1.1, let's do 1 through 5. So far we're going to do numbers 1 through 5. And then from 1.2, let's do 11, 12. Actually, let's just do 11 and 12. Bet you're happy about that. And then from 1.3, oh, actually, I like more. Let's do 24, 25, 26. So 11, 12, 24, 25, 26. Those are super easy. But I want to make sure you guys know what you're doing. And from lesson 1.3, let's do 1, 2, 3, 4, 5, 31 through 35. And then from lesson 1.4, let's do 39 and 40. Okay. So there's 5, 6, 7, 8, 9, 10. Here's another 5, so 15, 16, 17. So instead of 20 questions, I cut it down to 17. Okay? So that is your homework. It starts on page 16, and you're doing these problem numbers, and this will also be up in Google Classroom. So there you go. Make sure you take a clear picture. When you're taking a picture of your assignment, please make sure it's not sideways. That's hard to read. And if I see that, I'm going to tell you, can you resubmit that? Because I don't want to grade it sideways. Okay, I'm not going to turn my Chromebook sideways to be able to grade your work. It needs to be upright. And please make sure that it is clear, because I'm going to be zooming in on your answers and your work. Please show all your work. The only way you can get full credit is to show all your work. Okay. And basically all the steps that I show you in the examples are how you're supposed to show your work when you turn in assignments to me. Okay. So it's pretty straightforward. Have a great day.